Hello team, in this video we're going to talk about some limitations related to end-to-end traffic to and from data centers. Whenever we exchange traffic with an application that's running on a data center, our traffic must traverse the internet. So traffic will leave our home or our phone, and then it will traverse our internet service provider, some other networks in the internet, and then reach the data center, and then we can access that application. And this transit incurs additional latency. So many applications do not care about latency. For example, video streaming, most web applications, most mobile applications, downloads. So these applications don't care a lot about latency. So paying for a few milliseconds to traverse the internet is not that big of a deal. But some applications do care about latency. For example, gaming, teleconferencing, self-driving vehicles, telesurgery. So some applications are very sensitive to latency. So for these applications, having this additional latency for traversing the internet to reach the data center might be unacceptable, or it might limit what the application can do or how well it behaves. To offset some of this problem, cloud providers deploy data centers across the globe. And one of the reasons for this is that if there's a data center close to a client, then the amount of networks and the distance to reach a data center decreases, and the latency will also decrease. So here is an example of Google's footprint. So there are a lot of data centers. These data centers provide additional compute capacity, additional network capacity, but they're also located closer to users, which reduces latency, which is good for some applications. And here's a screenshot from Microsoft's website where they describe their infrastructure. So we see that there are a lot of data centers spread across the globe. So here I captured the US and Europe, but if you scroll the globe, they have infrastructure across the globe. And it's not only data centers. So we also see some links here. So Microsoft operates a lot of fiber, and these links ensures that Microsoft has a lot of capacity and good performing paths across the globe. Of course, one of the goals of having these gigantic deployments and global infrastructure is to improve performance. And cloud computing has improved performance and has improved latency. For example, I remember that when I was younger, it took around 400 milliseconds to go from Brazil to the US. So I couldn't play any games that were hosted in the US, and most games were hosted in the US back then. So because the latency was very high. But then, over time, this latency improved. So these days, it takes about 120 to 100 milliseconds from Brazil to the US. So this depends on where the server is located inside the US and where you're coming from inside Brazil. But, it ranges between 120 and 250 milliseconds. So this makes some games playable, but also because there are now data centers in Brazil, some gaming companies host their servers in Brazil. So this brings down latency even further to, depends on where you live. 30 milliseconds to 120 milliseconds. So now you can actually hit headshots. This is an example to show that cloud computing has improved latency. However, paying for this 100 milliseconds is still problematic for some applications. For example, telesurgery is very sensitive to latency. You don't want to cut, any millimeter past the point where you should actually cut. This is a big issue. Collision avoidance in self-driving vehicles, so you need very fast responses. And everything related to automation, like robots in the home or industrial automation, is also sensitive to latency. So for these applications, going over the internet to a cloud data center might be problematic. And the incurred latency is not the only problem that we have when we transit through the internet to reach a data center. So data centers have lots of bandwidth, so they can serve a lot of traffic, but these traffic traverses the internet, and it incurs transit costs on intermediate networks. And these intermediate networks might not be willing to pay for very high transit costs. For example, some applications require a lot of bandwidth, like Netflix and YouTube. So for these applications, transiting all of the data from the data center to millions of clients might be very expensive. And these transit costs are actually one of the problems related to net neutrality. So net neutrality is a very complex topic. We don't cover it here. But one of the issues in net neutrality is screening for these transit costs. So there have been several disputes over Netflix traffic. So Netflix generates a lot of traffic, and then it buys transit from some networks and not others. And then the networks fight between them about the transit costs and who should pay for the bandwidth that Netflix is using across the networks that the traffic traverses.